In section 3.2, example number 6, we're dividing x to the 5th plus 1 by the factor x minus 1. When setting up synthetic division, we want to make sure we are using all of the coefficients for each exponent, beginning with the greatest exponent, x to the 5th. That coefficient is 1. There is no x to the 4th, so we want to make sure we write 0 as our coefficient for x to the 4th, and 0x to the 3rd, 0x to the 2nd, 0x to the 1st, and then plus 1. We're dividing this entire polynomial by x minus 1. Since we're dividing by x minus 1, we are putting a 1 in the box for synthetic division setup. It's the value of x that makes that whole factor equal to 0. And then we list the coefficients, beginning with that greatest coefficient, 1x to the 5th, and then 0x to the 4th, 0x to the 3rd, 0x to the 2nd, 0x to the 1st, and then 1. That is our setup for synthetic division. We always bring down that first coefficient, 1, the leading coefficient, and we multiply all the numbers below the line by the number that's in the box. 1 times 1 is 1, and then we add all the numbers above the line, 0 plus 1, to get 1. We continue this pattern. 1 times 1 is 1. And 0 plus 1 is 1. 1 times 1 is 1 again. 0 plus 1 is 1. 1 times 1, 0 plus 1, 1 times 1. And 1 plus 1 is 2. That last number in your synthetic division calculations is going to be your remainder. And since our answer, or actually our problem started out with variables, we want to make sure our answer has variables. Our original exponent was x to the 5th, so when we are writing our solution, our answer, we're going to reduce that exponent by 1. So x to the 5th reduces to x to the 4th. So the coefficients of the x to the 4th, and then decreasing powers of x, and then that constant, and then the remainder, we can write our answer as x to the 4th plus x to the 3rd plus 1x to the 2nd, or just x to the 2nd plus x plus 1 plus 2, which is our remainder, over what we divided by, x minus 1. For example number 7, we're going to divide the polynomial, that third degree polynomial, by the factor x minus 1/3. There are no missing exponents, so we can go straight to the setup. Since we're dividing by x minus 1/3, we're going to put a positive 1/3 in the box. And then we list the coefficients, beginning with 9, sorry about that. My Apple Pen is not working. There it is. 9x to the 3rd minus 6x to the 2nd plus 3x minus 4. And then we are going to bring down that leading coefficient, 9, multiply all the numbers below the line by the number in the box. So 9 times 1/3 is 3. And then we are going to add -6 and 3 to get -3. Then we're going to multiply -3 times 1/3, which is -1. Then we're going to add 3 plus -1 to get 2. 2 times 1/3 is 2/3. And then -4 plus 2/3 is -10/3. That last number is always the remainder. Now we're going to write our answer, keeping in mind that our greatest exponent from the beginning was x to the 3rd, so we're going to reduce that power by 1. So we have 9x to the 2nd minus 3x plus 2, writing our answer as 9x to the 2nd minus 3x plus 2, that remainder of 10/3 over what we divided by, x minus 1/3. Now we want to simplify this one more step. Because we have fractions inside of fractions, we like to simplify that by multiplying the whole numerator of that fraction and the whole denominator of that fraction by 3. And then we're able to simplify this as 9x to the second minus 3x plus 2 minus a fraction. The numerator of that fraction is 10/3 times 3, which simplifies to 10. And the denominator, we distribute that 3, and we get 3 times x minus 3 times 1/3, or 3x minus 1. That is our final answer for the synthetic division problem for example 7.